Right, so to start off with association. So, what is association? Association describes how one object is related to another. So, this can have a one to one relationship, one to many, many to one, or many to many. So, it's a very basic description of how one object is related to another. So when you look into association further down, you get aggregation and composition. Now these two are forms of association, but then again they are specific to their own purpose. Right, so let's look into aggregation. So what this means is that the dependent object is standalone and can exist even if the owning class is destroyed. So if you look into the example of a bank and employee, where the bank is an object of the bank class, the employee is an object of the employee class. Now the employees are dependent of the bank. You see, as the bank hires the employee is dependent of the bank. So if the bank was destroyed, the employee would still exist. You see, even though it is dependent of the bank, it still is standalone and can exist even if the bank is destroyed. And that happens both ways. So even if the employees were destroyed, like so, the bank can still exist as it can hire other employees. Right, so that's what it means. And as you can see, it has 3 lines. So the bank is connected to each employee. So this means it has a relationship. It has a unidirectional relationship. So this means basically a one-way relationship, whereas a bank can have employees, but then it's one way because an employee can't have many banks, right? So that's what it means, right? Right, so moving over to composition. So what this means is that one entity cannot exist without the other. Now, previously in aggregation, we learned that 2 objects can exist even if the object of the owning class is destroyed, right? But when it comes to composition, one object cannot exist without the dependent object. So if you look into an example, so in this example, I'm taking an object of a car and a specific engine. So what I mean by this is that this engine is specific only to this car, right? So for instance, if you destroy the car like so, this engine will be rendered unusable. Since it's specific only to that car, you cannot use this engine for any other car. So this engine will be destroyed as well, right? So this works both ways. So if you destroy the engine, you cannot put any other engine into this car. So in turn, this car will also be destroyed. So that's what composition means basically. If you destroy one object, the dependent object will be destroyed as well. Right, okay, so I'm going to explain aggregation again in an example through code. Right, so I have 3 classes here. One class is student, the second is department and institute, and the main program. Right, so I'm going to explain just like basic explanation so that you understand the term aggregation. I'm not going to go in detail of this program here, but basically what you need to know is that the student class will hold student objects. The department class will hold a list of students. The institute class will hold a list of departments. So, and also within the institute class, there is a method called get total students in institute. So what that method does is that it goes to each department and count the number of students in there. Right. So if we go to the main program, we create 4 students. We add 2 students to a list, and then another 2 students to a list. And then now we have 2 lists of students, right? So we can add that to the department, which holds a list of students. So we create 2 departments, we add the list of students to the departments, and then we create an institute, and we add the departments to that institute. So then we print out the total students in institute and call the method get total students in institute. So when we run this, it shows total students in institute is equal to 4, which is correct. We have created 4 students and total number of students in institute is 4. Now, if you delete the department, right? So if you delete the department which holds a list of students, those students that have been created and put into this department will be deleted, but then the student class still exists. See, this class will, nothing will happen to this class. The student object can still exist without a department. A department is just a list that holds students. So if you delete this, if you delete the department, the students can still exist. So it goes both ways. So even if you delete the department, that just means that the students are not put into anything, but they can still exist on their own. They're standalone. Even though they are dependent on each other, they're dependent at the same time, they are standalone. So then again, they are showing the relationship of aggregation. One object can exist even if the owning class is dead, right? Right, so moving over to composition, I'm going to show you another example. So I have two classes, a book class and a library class, and the main program. Right, so again, I will just describe the basic explanation of this. I will not go in detail of the program, but it's a very simple program. So in the book class, it will hold objects of the book, and in the library class, it will hold book objects. So the library is basically a list of type book. Right, so in the main program, I will be creating 3 books as here, and I will set in the title and the author, and I will create a list of books, and I will add those books into that list. Right, so then now a library can hold a list of books. Right, so I will add that list into the library. So then I will print the title and the author within that library. So if you run it, it will just, I'm sorry, that was the before program. If you run this, yeah, it shows the title and the author, right? So when you run this, it shows the title and the author. So what this means, now I have created a, right, so now a library holds a list of books, right? So now once again, if you delete the library, you're deleting the books as well. So again, it shows the definition of composition, that one object cannot exist without the other. So since the library holds the object books, if you delete the library, you delete the books as well, right? So the books cannot exist without a library, right? So that is the end of the video. Thank you, and see. Right, so to end the video, we'll go through the differences between the both aggregation and composition, right? So when it, in terms of dependency, aggregation implies a relationship where the child can exist independently of the parent. Like, so for example, the bank and employee, delete the bank and the employee, still exists, whereas composition implies a relationship where the child cannot exist independent of the parent. Example, the human and the heart doesn't exist separate to a human. Right, so the type of relationship, aggregation has a relationship, and composition is a part of relation. So like previously in the bank employee example, that is an example of aggregation. It has a relationship, it has a unidirectional relationship, that is one way, and that is the relationship. So that is has a relationship, and composition is a part of relationship. So both of the objects are part of each other and cannot exist standalone, right? So that is what that means. So the type of association, composition is a strong association, whereas aggregation is a weak association. Association basically describes the relationship between one object and another. So why do we say composition is a strong association? So composition means that one object cannot exist without the other, right? So that means if you delete one, the other object gets deleted automatically. So that means it has a strong relationship, right? But in aggregation, if you delete one, the other object can still exist. So that means it has a weak relationship. That is the end of the video, right? So thank you for watching.